The table is several points that form a line on a coordinate plane. All right, we're going to use our y2 minus y1 over x2 minus x1. We can use any points we want to. I'm just going to go with the first two. Y's go on top. So I'm just going to subtract 5 minus 4 and subtract 4 minus 2. So 5 minus 4 is 1. 4 minus 2 is 2. So I have a slope of 1/2. Okay, the y-intercept, I can't see anywhere on here where I have an x of 0, so I'm going to need to work backwards. So on the table, I'm adding 2 each time. So to go backwards from 2, I subtract 2 and get to 0. My y's are adding 1 each time. So to go backwards 1, I'm going to subtract 1, so my y is 3. This is my y-intercept when x is 0. My y is 3. All right, number 7, again, we have the table. And again, we're going to find the slope and the y-intercept. All right, and again, the slope is going to be the y's over the x's. So I can subtract any 2 points, so I'm not going to worry about the one with a negative. All right, my y's go on top. So I'll just use these 2 in the middle, and I'll subtract 4 and 1. And I'll subtract 3 and 2. So I get 3 over 1. So I get a slope of 3. Again, I need to work backwards to find when x is 0. And so my x's are counting by 1. So to work backwards, I just subtract 1. My y's are adding 3 each time. So to work backwards, I would subtract 3. So -2 minus 3 is -5. So my y-intercept is at 0, -5. We have another table, same thing. Okay, I need my y's on top and my x's on bottom. Again, I'm not going to worry about the negative because I can use any of these points. I'm just going to use these 2 middle points and subtract 6 and 2. And then my x's go on bottom, so I'm going to subtract 5 and 3. So 6 minus 2 is 4, 5 minus 3 is 2, and that simplifies to give me a slope or a rate of change of 2. 3, 2, 1. All right, so on number 8, we need to find the y-intercept, and we're going to use our table and we're going to work backwards to get there. We're trying to get x to be 0. That's when we have our y-intercept. So my x's here are counting by 2s. We're adding 2 each time. And my y's are counting by 4. We're adding 4 each time. Really?
Sorry, my allergies are acting up.
Okay. All right, so are we through with the boogers?
Yes.
Okay, if the video is not working. All right, to get our y-intercept, we're going to have to work backwards. And we notice the pattern here. We're adding 2 each time on our x's. And we're adding 4 each time on our y's. So we want to work backwards till we get x is 0. So I don't want to subtract 2 from 1 because that'll take me past 0. So I'm going to need to half this difference. So instead of subtracting 2, I'm going to subtract 1 to get to 0. So instead of subtracting 4, I'm going to subtract 2, which would put me at -4. So my y-intercept would be a -4. All right, on number 9, we have triangle PQR and RST, and they're similar right triangles. And I want to know what's the slope of line PR. So I'm going to just use rise over run in this triangle and count up 1, 2, 3, 4, and over 1, 2, 3. And this is sloping down, so this is a -4/3. I want to know what the slope of RT is. So I'm going to use this triangle. 1, 2, 3, 4, 5, 6, 7, 8. And over 1, 2, 3, 4, 5, 6. Again, it's negative. Okay. And I want to describe the relationship between the slope of line PR and line RT. Well, if you notice here, I can reduce or simplify this to be -4/3. So they're both -4/3. So the slope is the same. No matter where you are on the line, no matter what triangles, what points you pick, the slope's always going to be the same for that line. All right, for number 10, the graph shows the total cost for party invitations, which includes a design fee. what is the slope of the line shown for this graph? So my slope is always going to be that change in y over the change in x. The y goes on top. So I'm going to look and see how my y's are changing. Okay, so that's the cost. So if I look right here, I'm going up from 15 to 20, so that's a difference of 5. And my x's are changing from 0 to 10. And then when I simplify that, I have 1/2. And this is a positive slope. Well, 1/2 is the same thing as 50 cents. So this is 50 cents per invitation because this is our cost per invitation.